In answer to the question, when are we ever going to use this stuff? This application was developed during World War II, so this is old stuff. There's two microphones at A and B, and we've graphed them right here and right here. Two microphones at A and B. And they're a mile apart, okay? And they record an explosion. We're kind of thinking the explosion's up here. You know, I suppose it could be down here, but that's in the ground. So, according to our picture, you know, they're on the surface of the Earth here. And for our purposes, the Earth is flat. And at least a mile apart. There's not too much curvature. If you worry about that, you should be in a different class. Anyway, assuming the sound travels 1,100 feet per second, you know that the explosion took place 2,200 feet farther from B than from A. So here's your 2,200 feet right there, okay, as shown in this figure. The locus, or the location, of all points that are 2,200 feet closer to A than to B is one branch of the hyperbola. So there's this hyperbola that we're thinking about, and, you know, it's on this side. Yeah, sure, there's another branch over here, you know. But we don't care about that branch, you know. We don't care about it. By the way, another thing that we did that is super useful is we put the origin right in between A and B. So it's a half mile to A and it's a half mile to B from the origin. That's, talk about useful. That's, well, why complicate it? So, I know that the focus on the right here, A and B are both foci, but the focus on the right is half of a mile, which is 5,280 feet, so C is 2,640 from the origin at 0, 0. Okay, so having said that, now it's time to think about, let me ask you one more thing, and maybe I'll get rid of this hyperbola drawing. Our drawing says that this is the same distance as this. If B were located on the top of a skyscraper or something up here, then it would have heard it. If it happened right here, if B were on top of a tower, really tall tower, and then it would have happened. They would have heard the explosion at the same time. So hopefully those branches look like they're equal. Hopefully those blue highlighted branches look equal. Okay, just saying. That's the idea. Okay, now you have that in your mind. Now let's look at this. What happens if it was flat on the ground? Then the 2,200 would be right here, and this is where B would have to be if it were flat on the ground. If the explosion happened on the ground, then you have two segments of the blue. One on this side, oh, that's beautiful, and one on this side. Okay, so I didn't mean to make that seem like one long blue line. They were the two blue lines that used to be up here. They used to be up here, now they went flat on the earth. If the explosion happened, you know, right in the middle, if the explosion, wait, wrong spot, sorry. If the explosion happened right here, then there would have been the same delay. Here's the delay. And then, you know, equal. D1 equals D2 after you get past the delay over here. Here's the delay over here. This is D3 for delay, I guess. Distance 1, distance 2, and delay. They all start with D, sorry. Okay, so anyway, hopefully that makes sense. We're laying it flat on the x-axis. Same thing as, we know it's up in the air. It didn't happen on the earth, but if it were to do that, this is what we're saying. And I hope you can see that right here is the focus. A is the focus. Remember I said A and B are foci? Okay. And then here's the vertex, right? If this is my hyperbola, beautifully drawn by me, if that's my hyperbola, then here's my vertex, right there. There's my vertex. So here's A, and here's C. That's how far they get. Okay. With that all in mind, hopefully this makes sense down here when it says C take away A. because I have C this far out, and I take away A, and I have the now green section in between, okay? That section is the same as this section on this side, okay? Now it goes past the origin, but they're supposed to be equal, okay? And it gets me over to this point here where the difference starts from, this is the 2200 lag right here. And it's not from the origin, you understand? It's not there. It goes past the origin. So this distance C minus A takes me over here, right there. Okay? And then I want you to think about something else. I have 2200, I have C minus A on this side and C minus A on this side, but they're supposed to equal. My problem told me it was a mile apart, okay? So if I go through all those motions, I find out, and I plug in, I know that C is half a mile because it's right in the middle. The origin's right in the middle. So C going out to A is 2640. The only thing I don't know in this formula is A, and I can solve for A right there, which I did. You can go through, if you don't believe it, and do the algebra, and it will happen the way we said. Okay, so this is great. Now I can say, I can find B, because I know that for a hyperbola, C squared is equal to A squared plus B squared. And if I solve for B, it's C squared minus A squared, right? Okay. And that lets me solve for B squared. And I put it down here underneath. Why? Because obviously I have a horizontal horizontal hyperbola. And now I know the equation somewhere on the right branch. I don't know where it happens, but I know it's on the right branch. And if I had a third person listening, maybe over here or something, then I could pinpoint where, if I knew how long it took them to hear. But anyway, I don't. So I just have to say somewhere on the branch, somewhere on that right branch. Yeah.